Welcome to the channel where all you gotta do is, well, you know, I'm gonna modify these rotors or these calipers to fit on the rotors I'm using. So the way I'm gonna do this is I'm gonna bolt this to the table like that. Which I was thinking this would be super flat, but it's not. Kind of rocks. Put it on the granite plate. I don't know if you can hear that rocking, but it's not because the table's crooked. But anyway, I'm gonna bolt this down, make a skim cast pass across here, and then I'll flip it over, put some strap clamps on there, and then I'll be able to, so I'm gonna make this surface perpendicular to the mating surface, and then fixture off of this newly constructed flat surface, which is just cast right now, and then machine it. So that's the plan. We'll see how it goes. So I got me a little piece of plastic under here just to make sure I don't mar the surface up. Anytime you're clamping a part, try to clamp through a section that's solid. Otherwise you'll warp the part. I mean, everything's a spring, so it's still going to compress, but if you're going through a solid, right, it's not the bending stiffness, it's the modulus, which is way, way stiffer. Okay, so I got this thing clamped down. I put 2 clamps on it because 1 clamp, don't ever try 1 clamp. That allows it to pivot, and if this thing grabs a hold of it, and just don't do it. Bad form. I'd really like to have a better fixture for this, but I'm only doing 2 of them, so we can do some MacGyvering. I did take the flywheel out and put this shear hog cutter, which makes a pretty nice finish. It's a carbide insert with a lot of helix and a lot of rake. So it should make a nice finish on here. I also indicated this in. It's within about 5 thousandths from high to low, from all the way to this side, which isn't great, but I have a feeling that's how it was because this thing rocked on the table. So when I clamped it down, it warped it into the flatness of the table. And then I cut that flat, and now it's just sprung back because there's no load on it. So, if anything, this will probably be flatter than it was from the factory, but it might be a little bit out of perpendicular, which the pads will wear that. As long as it's, you know, reasonably close, I think you're fine. If not, I'll post a video on it, but that'll be a year from now. So, get a better view over here because I'm going to be standing right in the way as per usual. Okay. Okay, so that's all done. Nice finish. Beautimous. So I might actually flip this thing back over. Well, I'm going to do this one next. But I probably will flip this thing back over and use this shear hog on this surface to make it pretty, because that's going to be kind of exposed through the wheels. And that looks kind of shitty with the fly cutter, but this looks real nice. So I think I'll update that, but we're by no means done, right? Because this hole used to be, you know, over here-ish, and now it's over here-ish. So I got to make a slot, and I'll show you that a little bit later in CAD. But I have to make a slot, but I have to make the slot on the opposite side because, well, moving this one down shifted it that way. So if I put the counter bore in this side, it's going to shift it that way even more. But if I put the counter bore in the opposite part, it will shift it in the direction I want. So instead of having 300 thousandths of slot width to come in and turn, I'll only have 200 thousandths, and then the O-ring that came in this will still work. So remember when I said it was complicated in the last video? That's what I was talking about. But I'll go through it a little bit more. So this is a very simplified representation of what the caliper is, but that shows where the O-ring used to be and the angles of the holes and how they kind of line up to each other. So what I'm going to do by chopping 360 thousandths off, about 9 millimeters, it'll end up looking like that, which you can see the holes aren't lined up anymore. And then I will shift that thing up until it does line up, and you'll see that row, Houston, we have a problem here. But if I put a counter bore in the bottom side there, it's going to move that hole even farther to the left, and now the span between the top hole and the bottom hole is even farther. So instead, what I'm going to do is put the counter bore on the top that holds the O-ring, and then that O-ring will shift the top hole to the left, and then everything will be good in the world. And it'll kind of look like this. So yeah, so now zoom in a little bit here. You can see there's no room for an O-ring. I didn't draw the O-ring in there, but there's room for an O-ring on that side, and there's room for an O-ring on the other side. So instead of using a different O-ring, I'm just going to take the it is actually a 1/2 inch OD O-ring, and I'll squish it into an oval, and then they'll fit right in that slot. Okay, so I got the outer parts of the calipers all machined up. I did the first one, I finished the second one. And then what I did was I just kind of scribed on here. I don't know if you can see it in the die cam. That's approximately where the other hole on the machined version. I took like 9 millimeters off of here. I have this kind of cheesily fixtured, but that's fine because I don't know how accurately these little tabs are machined, but doesn't matter because I'm going to check it. So we'll just go down to that's 0. And we'll crank this back and forth. It really only needs to go to there, so that's 0. And 200 thousandths, still 0. So that's pretty flat. And then the other thing I did, I got this gauge pin that slides in here. Like that there. And then what I did was just go, I'm trying to run this mill and steer the camera at the same time, so apologize for that. Alright, so that's about, we'll just make it 0. Alright, so that's 0. And then we move over a little bit. Still 0. Yeah, 4/10. So that means I have this caliper on the mill, and this hole is on this axis, on the x-axis. So the slot I put will go from that hole to where the other hole was, because the holes are on the same angle. Essentially, these are mirror images of each other. So now that I got this set up, I can use the same indicator to indicate the center of this hole, which is not round. There is like a spot face that's round, but I think I'll indicate the ellipse, call that my 0, and then I'll machine a slot that's, I have to go back in the CAD and look, but it's 57 thousandths deep. So there you have it. That's the O-ring that you do, and he lost it into the sack of chips. So yeah, it used to be like that, and now it's like that. You won't know. So there you have it. It's off the mill now. That's the little O-ring. Check this all out. It's 57 thousandths deep, just like it's supposed to be. And that thing's a little bit harder to get in there than it used to be, but it's in there. And just a visual. I don't know how well you can see that, but they look like they line up pretty good. We'll know the first time we step on the pedal and it doesn't squirt goop out of there. You know, goop. And that's what it looks like. Now it's just a matter of taking all these, because chips got inside here. So I'm going to take these out just like I did this one and clean it all in the solvent tank and deburr all this. There's little burrs here and there. Obviously I got to do the other one. So a couple of more pieces of information. Whether you care or not, I don't know, but since we shortened this doesn't line up very good anymore. There's a little step there. Just be aware that's going to happen. These pins need to be either drilled for this retainer thingy, this little guy. So I just need to drill a hole 0.36 inches away from that hole, no big deal. Then this thing here, which does a couple of things, but mainly it pushes these pads down, take the backlash out of them. That's obviously too wide now. So what I'm going to do is cut along this dotted line here and here, move each one of these over 180 thousandths, and then weld that back together. This looks like stainless, so 40 thou thick stainless is pretty fun to weld, but you can do it with a TIG welder. One other thing is these bolts are too long, obviously. So you can see this one here. These little ones on the outside tighten up, but the big ones, they run out of thread here. So I'll have to get some shorter bolts. Okay, so there's the second one all machined up. Look how pretty that is. Just let me know what I'm doing. Don't tell anybody. It's a secret. Okay, so I pulled the piston out of this guy here, and look at the fun little nut surprises. So that's why I'm taking it apart, because even though that's a tiny little hole, those little chips get down in there. There's also a cross drilling from here. It's unlikely anything got into here, but I'm going to take that apart too. Clean this all up super nice and put it back together. I already took this one apart. Cleaned it all up, put it back together. Set that over there out of the way. Show you how I did this. These are your standard snap ring pliers. And this is just a piece of metal that's laying in the scrap bin. So I put it on the expandy snap ring. Just kind of twist and jiggle. Once it starts moving, it moves pretty easy. Static versus dynamic friction. And then, once it's up far enough, you can pop the seal off of here. Doesn't take too much effort. Now you could get the outside of the seal off before you pull it up, but you can't get the inside. So you have to get it above there, because otherwise the seal's trapped. So we'll clean that up later. And then it doesn't take much force to pry these out, but you have to do it symmetrically. You can't just pry it on one side or it gets kinked in there. So just take, you could use a plastic stick or screwdriver, like probably the little doodads to put a new tire in your bicycle would work pretty good, but you just put a little bit of force on opposite sides and it kind of just pops out super easy. You don't want to force it for sure. You want to mar the surfaces up, but there's a handy dandy little undercut on here that you can use to pull it with. Again, just be gentle with it. It doesn't want to fight you, but you gotta be aware of how you're prying it out. Because if it gets kinked in there, then you're kind of screwing it. Don't do that. There you go. And that one's nice and clean because that wasn't on the machine side, but I'm double checking anyway. This just looks fluid. It looks a little bit funky, but not too bad. So, and then to get the seal out, just take a little pick like this. Be careful not to scratch it. Like that. Obviously, installation is reverse procedure. You clean this all up, put this back into the little groove, take the piston, slide it in. If you just kind of push a little, it'll slide down, and then put the seal on, which has to go around this little lip here, and then around this little undercut in here. And then cleaning off the bottom of the piston part where there might have been chips, and then taking this little bit of grease, wiping it on there, just to make it a little bit easier to install. Not that these are particularly hard, but just kind of jiggle them. Don't force them, just jiggle them a little bit until they succumb. So with this, I already cleaned it. But you can see there's a little bit of grease up there, that yellow stuff, which isn't going to do any good up there. So it's kind of like deep groove ball bearings. They put grease on them, but they always put more grease than needed because it's easier to overfill it and be safe than it is to underfill it and not be safe. So in the scheme of things, it's a couple of cents worth of grease total in a bearing. So putting 2.2 cents in doesn't really hurt their bottom line that much. So whereas a failed bearing, customers don't appreciate those. If you're ever repacking deep groove ball bearings or any kind of grease pack bearing, the best way to do it is to weigh the bearing, put the grease in, weigh the bearing again. Do it by mass. And you don't know how much is in there, weigh it before it's used, if feasible. That's the way I used to specify how much grease went into bearings. Back when I had a real job. Okay, so now we just gotta migrate these guys down a little bit. I don't know if you can see what I'm doing, but it's kind of like putting a piston ring on. Just get it over the lip and then work it around. Like that. And these don't really do anything, these seals. These are just like to keep moisture and stuff out of the piston, right? It's just a protect it from environment seal. It's not really doing any critical work, which is good because if you take your car with stock brakes to the track, this is the first thing that melts. The hot gases and brake pad material kind of shoots into these guys and well, makes them no good anymore. Maybe some cars with big enough brakes, but my wife's '01 Mustang with an Allen supercharger on it made it about 70 miles at Buttonwillow before the brakes were completely cooked. Anyway, this one's going to be the same. No use wasting megabytes worth of data storage. I'm going to do the same thing in this guy. Take it apart, blow it out, put it back together. I cut this guy, move it in basically 3/16 of an inch, tack weld it back on there. And this is just, this provides a little bit of, see that angle on there? That pushes down on the pad, which spreads it back out. So the purpose of that is twofold. One, the square O-rings that do the sealing, the way those work, or the way those are supposed to work, is, so you have your caliper like that, and then you got your O-ring in here like that, and then you got your piston, right? Center line. You put fluid in there, it pushes the piston out, right? Pretty simple. Well, when this piston moves, basically it doesn't slide on this rubber. It basically takes the rubber that's on this side that stays fixed, and then it kind of makes it look like that when it deploys. It just flexes the rubber because there's friction between here and here, and so it flexes the rubber, and then when you get off the brakes, this rubber tries to go back to straight, and so it retracts the piston back a tiny bit. Every once in a while it does slip because the brake pads wear, but it's, you know, 1 out of 10,000 brake applications. The majority of it is just flexing and then popping back, flexing, popping back. And when the brake pad wears, when this wear surface wears down, then that one time it doesn't retract, right? But the next time you put the brakes on, it does. So, and that's for obviously reducing brake wear, but mostly it's for reducing friction. So when you're driving down the road, it isn't like a drum brake where there's springs that pull the drum brakes away from the drum, pulls the shoes away from the drum. That's what that job is. And this adds to that, right? It has a little bit of an angle there, so that acts as a spring, and it pushes the pads back out. So. So these are all back together. Look at that. Like a butter. So there you have it, folks. Somebody tells you something's impossible, don't believe them. Thanks for watching. If you like this content and want more, subscribe, like, and share.